Okay, on number, I don't think it really is 25, this should be number 27 on there. Is there a relationship between type of examination, problems only, multiple choice, problems and essays, matching essays and problems, type of exam, and whether or not students pass the exam? The alternative and null, or the research and null, the null will be that there is no relationship, there is not a relationship between type of examination and whether or not the students pass. And then the research or alternative is that there is a relationship. So for the alternative or research, you could just take that is and there, switch the order of them, and change the question mark to a period, and you've got it. That would be the alternative. Then for the null, just add a not a relationship to that. HO not, HO is a relationship. Okay, for the critical value approach, that means we're going to use a table, the chi-square table, which is the one that I gave you, and we're going to use a value off of that and decide when to reject HO. For a chi-square test, we'll always reject HO when the value that we compute for the chi-square test is greater than the value that we look up on the table. So to look the number up on the table, the first thing we're going to need is a degrees of freedom, and I'm assuming alpha, actually it says it here, alpha is equal to 0.05. The degrees of freedom will be number of rows minus 1 times number of columns minus 1. And we have 4 rows, so 4 minus 1 times 2 columns minus 1, and you get 3. And so we'll reject HO if the chi-square test is greater than 7.82. By the way, you could also just mark through one row and mark through one column, and then there's 3 cells left. That is the degrees of freedom. So we're going to reject HO if the chi-square test is greater than 7.82. Okay, we're going to need expected values. The chi-square test formula is the sum of the observed values minus expected values squared over expected. Actually, I kind of put one too many parentheses in there. Sum O minus E squared over E. The observed values are the values that were given in the problem. That's what we observed. And the expected values then will be what we expect if there's no relationship. Since our data are a 4-way split, 50, 50, 50, 50, at least depending on when you printed the exam. I originally had made a mistake and called that 8 instead of 9, but let's make it even. That means that 1/4 of the total values in a column should be in each cell. Since we have 158 in this column, 1/4 of 58 is 39.5, 39.5, and just put that in all of them. And then 1/4 of the 52 will give us the expected values of 10.5. Another way you can do that, which you would have to use if you didn't have like a 50-50 or a 1/4, 1/4, 1/4, 1/4 split or something like that. You can always get expected value. Let's do it for this cell. You take the row total, multiply it by the column total. So that's 50 times 158, and divide it by the overall total, 200. And that's going to give you 39.5. If we were doing this cell, we would get the row total times the column total, so 50 times 42, and divide by the overall total of 200, and that'll give us 10.5. There's 2 ways that you can get the expected values, and I'll show you in a minute. You can also get those from your calculator. And so here I've just where I've shown all the work to work this out. So you can see there are the observed values, then there's the expected of 39.5 and 10.5. So for this cell, I take observed 41 minus the expected 39.5, square it, and divide it by 39.5. I got 0.057. If we jump down to this bottom right scale, one cell, I get 5. It's observed minus expected minus 10.5. Square that difference and divide by the expected value of 10.5. So I've circled all of those there, just sort of a mechanical way for me to know those are the numbers I'm going to add up to get the final chi-square test. So the chi-square test is equal to the sum of all of those. That comes out to be 7.854, which is greater than 7.82. Not by much, but it is. So we reject HO and conclude that there is a relationship between the two. Now what I want to do is what I would like to do is show you how to use your calculator to work through the math in this problem. A little bit different than some of the things we've done before. Second, matrix. And we're going to go over and select Edit and hit Enter. Second, matrix, Edit. And then tell it the dimensions of the matrix that you're looking at. We have a 4-row by 2-column matrix. And when you do that, it's going to open, put a space down here for you to put the numbers. And so just put in 41. See, it used to be 8 there. I want that to be 9. 34, 16, 38, 12, 45, and 5. So you've entered the numbers into matrix A. Those are my observed values. Stat, test, arrow up or down until you get to the chi-square test. Not the chi-square goodness of fit, just the plain chi-square test. That's the test of independence. It'll do the test of independence and another one, but tell it where you put the observed values, A. Never change this. Let's just always put them in A. Tell it where, as it does the calculations, it's going to compute the expected values. And what I'm saying here is put those in matrix B. That way, if I want to go look at them, I can. If I don't want to look at them, they're still going to be there, but you can. And then just hit calculate. So when you're running the chi-square test here, really the only thing you ever do is hit calculate. Once you've put the values you want into matrix A, just come here and run the test, calculate. And then you can see there's the chi-square value of 7.836, pretty close to what we had when we did it by hand. And the p-value is slightly less than 0.05. It's less than 0.05, so we reject HO and conclude that there is a relationship. And there's the degrees of freedom that we had already computed in order to look up the value in the table. So the other thing I'm going to show you here is if I go now back to second and matrix, even if there hadn't been anything in B before, or even if there was something else in there before, running the chi-square will fill in, put a new matrix in B, and it'll be the matrix of the expected values for this problem. So if you just go over and hit Edit, after you get to Edit, arrow down to B and Enter, then you can see those expected values that we had when we made our computations a little while earlier. And that's it for the chi-square test and for this problem.